The new chapter which we're going to deal for today's session is linear equations in two variables. What is a linear equation in two variables? Let's recap with the polynomials. We have discussed about the different types of polynomials, initially with linear polynomial, quadratic polynomial, cubic polynomial, quartic and quintic, etc. So proceeding the similar manner, we are now going to deal with linear equations which are very much connected with the linear polynomial. And since I have two variables, the condition is that the polynomial needs to essentially have the two variables x and y, of course. So let's see in brief about the linear equation and its two variables and its respective definition. Before we go into the definition, let's get into introduction on linear equation to recap with the linear polynomial. As we know that the polynomial function denoted by p of x with variable x is linear if it has its highest degree of the variable as 1. Say for example, I have this to be ax plus b. In this case, I find that the highest degree of x is 1 and hence such a polynomial is called a linear polynomial in x. In the variable x. So clearly seeing this linear polynomial, I find only one variable which is x and its power being 1. Therefore, the degree of this entire polynomial is 1 and such a polynomial with degree equal to 1 is called a linear polynomial in the variable x. Now let me connect with what could be the linear polynomial in two variables x and y. So to connect with the linear polynomial in two variables x and y, let's see how we can define the respective definition of linear polynomial in two variables x and y. So let's reconsider the definition which says that a polynomial is linear if its variable is with power 1. The highest power is 1. Therefore, when I introduce the two variables x and y into the polynomial, then I clearly assume that I need to have both the variables with degree 1. So a linear polynomial in two variables x and y, unlike the one variable x, is defined to be ax plus by plus c, because each of the term has degree 1 with variable x here being degree 1 and this term equally having the degree as 1. Therefore, such a polynomial is called a linear polynomial in two variables. Here, this is a linear polynomial in one variable x, but because I have the introduction of two variables x and y, this is a linear polynomial in x and y, the two variables here being x and y. A linear polynomial in x and y defined to be p of x comma y equals ax plus by plus c, provided the condition a, b, c belong to real numbers. The three constants or the coefficients must be real numbers, and the rule 2 being a and b should not be equal to 0. They must be non-zero. A, B, C belong to R and A and B are non-zero real numbers is how I define the linear equation, linear polynomial in two variables x and y. Any example we can take for this would be, say for example, I have pxy is 2x minus 3y plus 4, then this is clearly with the first term being with degree 1, and coming to the second term, its degree also being 1, and of course the degree being 0. The highest degree for x and y is 1, and therefore this is a linear polynomial in x and y. Is how we define the linear polynomial. Now let's take an example problem where we do not have a linear polynomial. The contradictory to this example is what we are going to discuss continued. For example, I have p of xy is 4x minus 3x y square plus 4y minus 3. Let's see if this is a linear polynomial in x and y with xy. So let me just consider this example to investigate for whether this polynomial is a linear polynomial in x and y. So let's take the given example problem in which I clearly have my pxy to be 4x minus 3xy plus 4y minus 3. Now before I justify for its linearity in the polynomial, I have to search for the degree of each of the term. So coming to the first term, I have my degree of x, which is 1, of course, because x power 1. I have my degree of x, which is 1, and I have my degree of y, which is 1. Therefore, on the whole, I find this combined degree of the second term to be 1 plus 1, which is equal to 2. And next, I have my third term whose degree is 1, and I have, because its power is 1 for y, and then the constant term whose degree is 0 because there is no x or y attached. So x power 0 or y power 0 is what we assume. Therefore, I have, for the first term, I have this, and for the second term, I have 2 because the combined degree is 1 plus 1 for each of x and y, and then the overall degree for the second term is 2, and for the third term it is 1, and for the fourth term it is 0. Therefore, when I compare each of the degrees 1, 2, 1 and 0, I identify that the second term, which has degree 2, is not equal to 1. Now, because the degree is not equal to 1, the highest degree for the second term is 2. It cannot be a linear polynomial. For linear polynomial, degree must be equal to 1. The highest degree of the entire polynomial must be equal to 1. Degree 2 not equal to 1. Therefore, the given polynomial is not a condition, is how we understand the concept. So this is a linear polynomial in x and y, and this is not a linear polynomial in x and y. Now that we have discussed about linear polynomial, let's enter into discussing about a linear equation in the same two variables x and y. Linear equation in two variables x and y. Definition. So as we come across, let's recap with the linear polynomial, which is defined to be a polynomial p of x comma y is said to be a linear polynomial in two variables x and y if this is equal to ax plus by plus c, provided all the constants a, b, c belong to R and a not equal to 0 and b not equal to 0. Is how we define a polynomial with a, b, c belonging to real numbers and a not equal to 0 and b not equal to 0. So let's see how we can define the linear equation derived from the linear polynomial. So this polynomial p of x comma y equals ax plus by plus c is called a linear polynomial in two variables x and y if a, b, c belong to R and a not equal to 0, b not equal to 0. Now what is an equation? When does a polynomial become an equation? Is the biggest question in comparison. So as we see here, the linear equation is obtained when I equate the given polynomial to 0. So when I want to convert this into an equation, I just take this in the form equal to 0. That implies a linear equation in x and y is defined to be p of x comma y equal to 0, which is indirectly ax plus by plus c equal to 0. Therefore, a linear equation in x and y is finally concluded to be ax plus by plus c equal to 0, with a, b, c belonging to real numbers, as with the same condition as that for the linear polynomial. So a, b, c must belong to real number, and the second condition being that a and b should be non-zero real numbers, and a not equal to 0 and b is also not equal to 0 is how I define the linear equation in two variables x and y. Linear equation in two variables x and y. Ax plus by plus c equal to 0. A, b, c belong to R, and a not equal to 0, b not equal to 0 is how I define